Still working on your homework project. It's not as bad as the homework you're doing for the midterm, so don't worry too much about it. It should take like half the time or even like a quarter of the time. You'll be doing a doubly linked list as well as iterators over it. And it will need to be templated. So let's go and pick up from where we left off yesterday. We were working on Pokemon. But one thing I want to show you, for those of you that haven't been to discussion, this won't make too much sense. For those of you that have, it should make a bit of sense. Over here, I've written an iterator over the string class that we did in class. We just want to go through the individual characters. But you'll find that when you're writing iterators, a lot of the time, you have to write a const version and a non-const version, right? So that in some circumstances, you're able to modify things if you want to. In other circumstances where you only need to read, you have the ability to just only read, and so that it's still type safe. But when you're writing these iterators, you generally can't do inheritance, which we'll talk about next week, to get them to work, because you don't want them to be able to set a base pointer to both either a const or non-const version. You want their types to be separate, but the code inside of them is nearly identical. It's almost 100% the same, except like the non-const one has some non-const members and uses regular references as opposed to const references. So we can use templating to avoid having to write both versions, but it gets a little bit more complicated if you decide to do it this way. So here you can see we're templating our string class generic iterator. Our template type, though, is we fully specified it as being a bool. So when somebody passes in the parameter to the template, they need to pass in either true or false, some value of a bool here. You can see I do some using type defs. So here I can say I have a value reference type, and it's equal to std : conditional should be const char reference. This looks really complicated. What the std conditional does is it evaluates this first value. If it's true, this entire expression evaluates the first type. If it's false, this entire expression evaluates the second type. So if I pass in true for should be const, the type of value reference type will be const char reference. If I pass in false, the value for value reference type will, or the type for value reference type will be char reference. I also do the same thing for pointers, right? I have a value pointer type. If we should be const, we want const char pointers. If we're not const, we should be char pointers. Any questions here on conditional? Right? And again, remember the using gives me type defs. Using gives me another name for this value over here. The other thing that I have that's fairly interesting here is I have a template bool should be const underscore equals should be const. And there's this enable if. So if you do things this way, if this expression evaluates to be true, we will actually create this function. If this function evaluates to be false, we won't create the function. And you can see the function that we have over here is operator star, right? The non-const star operator. And we only want non-const star operator to be there if we're not supposed to be const. And the type of this, our return type will be char reference if this condition over here holds true. Otherwise, this code doesn't get created. Any questions here? And then finally, the only kind of interesting to think about is templates, like everything else, can be nested, right? So notice back here, I have this underscore should be const, right? He's inside the templated function. The template should be const. So it's a nested template. If you wanted to declare that outside the class, we have template bool should be const. Template bool underscore should be const. You just list it underneath it. So this template is inside this template. And you can see that I do a lot of things to list the types, so I'm actually accessing things correctly. And you can look at this example tonight when it's back on the class Google Drive. And then over here in string class, I have two more using things, using type defs. So I have a const iterator. It's equal to a generic iterator, true. It should be const. The non-const iterator, false. I don't want the const version. I want the non-const version. This saves me from having to rewrite the code twice. Normally, if you did this without the templates, you'd have two copies of that code. One that would be like, const string class iterator, The one would be non-const string class iterator. You have to write, copy and paste the code from the first one into the second one, and then just add one more function and change the constness around. Does this make sense? This is very advanced if you want to do things this way. And for your homework, you're more than welcome to actually use this, or you can copy and paste things and just have 2 different versions, so that's easier for you to understand. So back to Pokemon. So last time we left off, we said that in a Pokemon battle, right, we need to keep track of whose turn it was, and we needed to keep track of which Pokemon we're fighting. And we also said that we wanted Pokemon to be able to battle. And we also probably need a constructor to figure out how to, get things created. So what should a Pokemon battle take for its constructor arguments? 2 Pokemon objects, right? And here we might have const, I think, should be fine. Vector of Pokemon. And that's our constructor. And we'll go over here and we'll just create a dummy type so things stop complaining at us. Oops, not here. And we'll go ahead and we'll create our constructor. So over here, our constructor is quite simple. We're going to copy over the Pokemon into our Pokemon. So make a copy of them, and then our turn should be equal to, whose turn should it start as? Yeah, so it's 0, right? Because 0 is the entry of the first one. Okay, so that's our constructor. And now we want these guys to be able to battle. Explicit. Okay, so what's a Pokemon battle look like? Again, don't think about details. How would you describe how this game works? Yeah. Right, so we want to keep going until, one of them's unconscious, right? And each turn we need to figure out what move to use. We need to apply that move to attack the other person, and then we change the turn. Yeah. Yeah, so when we get into Pokemon, we will definitely do that. But right now, we don't want to focus on the internal details of the class. We're kind of like focusing on the interface, how we want to be able to use it, and that's why we're starting out here at a higher level first before we narrow things down. Yeah. So we might say something like while, or like, I guess we should say while. Well, I mean, you might say like is there, because it depends, let's assume there's only 2 Pokemon for right now. So you might say while all conscious, or while all Pokemon are conscious. Right? So while they're all conscious, what do we need to do? We need to get, an attack from whoever's doing it, right? So we might have something like attack equals get attack, or from user or something, right? So we get the attack from the user, whatever they happen to be doing. And then, yeah. Oh, because I thought I was in the battle. From the user. And then we might say, you know, get curve Pokemon dot attack, and he's going to use, you know, this attack to attack the, you know, maybe we should say like get attacking Pokemon, get defending Pokemon, and then we can say change the turn. And then afterwards, we might, you know, print a winner. Anything else that we want to add in here? Yeah. Yeah, and so we can add because there's like a lot of nuance to this game that we could add in, but right now we're not going to focus on that. And we could have something in here that like before the Pokemon battle starts, right? We might have something like order. I don't know, order Pokemon. We're not going to like, you know. It's bad, right? But we can have something here that's going to figure out like order the Pokemon to see like who goes first, right? And then we might have something like here. We might have something. We also need to like the get the curve. Everything seem good so far? Yes, I am recording. Right. So like what we could do right now is we could just leave this function as a dummy, and then later on we can actually have it do some work to see who's going to go first. So over here in Pokemon battle.h, this would be a private method. And so sometimes I do this as like a private members and private methods. So you might have something like void order. And for right now, we just don't do anything, right? We just throw in a stub here. And if we want to be able to add this function in functionality in later on, we can go and fill in the details. We also figured out that we need a new type called attack, right? So we're going to add in a new class called attack. Great. And then on battle, this needs to go into sure. All Pokemon are conscious. Sorry, this takes a long time. And it's going to return a reference to that Pokemon that we're working with. and then change turn. And then finally print winner. Ooh, okay. So let's just start with all of our Pokemon conscious. What do you think this would look like? Again, don't think about it like even in that level, right? We want to ask, we have a couple of Pokemon. What should we ask them? We just have to ask each Pokemon, are you conscious? Right? Are you there? Huh? Right? So we would say something like for const auto reference Pokemon in Pokemon commands, if not Pokemon dot is conscious. I can't spell, but you know, return false. Otherwise, at the end of the day, we'll return true. Right? Does that make sense? Again, we don't want to deal with the details till we absolutely have to deal with the details, right? We should be able to ask a Pokemon, are you awake or not? And it should hopefully be able to respond to us. Does this make sense? So great, we've taken care of this function, right? We're done with it, and you know, there's some details later on that we now know that our Pokemon have to be able to express if they're conscious or not. We also have to be able to change the turn. For this one, how do we change the turn? Like whose turn equals whose turn plus 1 mod by Pokemon's dot size. Right, so we add 1 to the turn and then mod by the number of Pokemon that are there. So if we had like 3 Pokemon and turn goes to like we're currently on Pokemon 2, that'd be the last Pokemon. 2 plus 1 is 3. 3 mod 3 is 0. Go back to the beginning and start at the front. Okay, get attacking Pokemon. It's not a trick. Return Pokemons at whose turn? Great. Right? Pokemon, over here it is a reference. You can see our return type is we're returning a reference to this guy. And this function also returns a reference as well. So we're all good. Get defending Pokemon. Well, we're assuming that this vector is never going to be larger than 2. For right now, right? We could go later on and we can make this work differently. But it's nice because like it's in a function. Yeah, we could do that now, or if we kind of wanted to make it like a little bit general, we could just like have it go through and say like, hey, are you equal? Like, you know, the address is the one that's not equal to who we are. So we could do something like, again, for const auto reference Pokemon in Pokemons if the address of oh, I can't do that, can I? Have to have an iterator. Oh, I don't want to take its address. I want to call it. There you go. So what this simply does is we go through each of our Pokemon and we see which is the one that we're not talking about by comparing their addresses, because we know they're in the vector. I don't actually have to compare their values. If we wanted it to maybe be a little bit safer, we could compare their values to see if they're equal, but then the Pokemon have to define an equality operator. Or again, if we're assuming right now for 2 people, we could just do more or less whose turn plus 1 mod Pokemon size, plug that into Pokemons.at. So this like returns the first Pokemon that does in the list of Pokemon who's not the attacking one. Any questions here? This is a little bit more complicated way of doing it, but maybe might be a little bit more extensible for the future. Okay, and now we've pretty much done everything here that we need to do, right? We've more or less finished the Pokemon class except for like printing the winner, which we'll come back to that later on. But now you can see that we've defined a couple of things. Like we need to know if a Pokemon is conscious. We have to be able to somehow like get an attack from the user, right? Which is, do we do this one somewhere? Right? Somehow we need to write this function still, but we may not have enough details, but maybe we do have enough details here. So how would we want to display this function over here? What should getting an attack from the user be? How do you want to display to them what to do? So we have a do while loop for getting valid input, but like one of the things that we need to do is like get what attacks the Pokemon has, right? Because different Pokemon can have different attacks. Agreed? Yeah. Well, yeah, we're going to have an attack class, right? Because Pokemon have attacks. It wouldn't be a child class. It would be a member, right? But maybe we'll leave this one off right now because you guys don't seem too keen on what needs to go here at the moment. So maybe some more details somewhere else. So what does a Pokemon have? Right? They have like an int per health. What else do they have? So yes, they will have an std : vector of attack called attacks. They probably have a name, right? They might also have a type. What else? So I'll list some of the other things that we could go on later. They have a type, right? They're gonna have like various stats, right? Which we'll leave those things, right? They could have like an item that they hold. They could have a type if they needed to have a type, or they grass type, fire type, whatever. There's a ton of stuff that could be there. But for right now, we're gonna keep it simple, and they're just gonna have a name, health, and some attack, right? And we'll leave it at that. So we probably need some functions. One function we need to figure out is our Pokemon conscious or not? So bool is conscious. Let's steal that from over here so I don't misspell it. What else do we want a Pokemon to be able to do? We want a Pokemon to be able to attack another Pokemon, right? So attack, and then we need a Pokemon reference to a defender. And because attacking is going to be changing that defender, we are not going to need to change, we're going to need to change it because its health will go down. It depends, because if you think about it, like each attack has some PP, like power points associated to it. Yeah, I mean, but so like for the future, like you might change, or you might have attacks that have recoil, right? And you hit somebody, and so you hurt yourself too, so you would change. So for future, changes, if we ever need to make them, we have the capability of changing ourselves. Yeah, the attack, we also need to have a... And then we also needed something else, right? I think we said... that we needed to be able to... we haven't done that yet, so maybe we have to have something where like we're able to get that person's attacks, right? So far this seems good, and we'll figure out later if we need other things. So what should is conscious do? Turn your current health greater than 0. Great, you're conscious. And then we also need to be able to do an attack. So what should happen here with this attack, if anything? So we can have like we can get the damage from the attack, right? And then just like subtract their health. Yeah. Which isn't that what this function is? So like you want to receive an attack? So we could so if we do Noah's proposed method, we would just have something like defender dot receive attack. Right? And then we've kind of like thrown our problem back to where we more or less have the exact same thing, right? It hasn't changed that much, because here I think we'd be doing like the exact same thing that we'd probably be doing up here. Or I think more what you were trying to go with is maybe something this like attack dot apply to the defender. Right, apply this attack to the defender, and then the defender can, or the attack can figure out like how much damage it's going to do to it. There are some other things that the attack though might need if we wanted to like fully do everything, like the typing and whatnot for the damage calculations. So again, I'm not sure if this is going to help us out too much, but we'll just put it here for posterity. So we might just, for right now, we'll just say like defender dot her health minus equals attack dot get damage. And we'll leave it at this for right now, and we can go in later on and see if we need things later on to do it. And then I know your question was if we wanted to make sure that their health stopped at 0 or not. So if we want to make it stop at 0, we can say, defender dot cur health is equal to std : the max of defender dot cur health and 0. And their health swaps at 0. I mean, that's just saying that their health stops at 0. Any questions here? Yeah. Say it again. Because we need to know which of the attacks to apply to the defender. right? Because you're right, the Pokemon has multiple attacks. We need to know which one of those attacks are we supposed to be using to hit them with. Right, and then we've come up with, now we do need to still come up with a constructor and figure out how that's going to be initialized. So we'll get there. But then we also need an attack. And private. What does an attack have? An attack has a name. And what else does it have? Right, or an int damage value. And then again, if we really wanted to keep going on, right, with Pokemon, like attacks have types, and right, like it's like a bug type attack, or right, and then you can also some attacks like apply conditions to them. So like going back to like what Noah was saying earlier, we might need to like have more of like an apply method to figure out, well, does this attack cause confusion or cause poison or cause sleep or whatnot, to apply that to them. Then Pokemon need to have like a status, like am I at normal status, or I'm at like poison status, or I'm whatever. And then you might need to be like at the beginning of each round, apply the status. That's kind of like how they work, right? Like at the beginning of like the poison round, you'd like lower their health from that status. If their status was sleep, you'd kind of just like skip their turn. Right, and so like applying that status might happen back out here inside the Pokemon battle, because before we get somebody's attack, we need to apply the status. So you can apply statuses here if you wanted to do that. We'd also need some way to know, like, some of the statuses are like apply to Pokemon, like they like injure them or something, but some statuses also apply when you're doing an attack. So we'd also have to see like if it applies there, or ask for like if you're confused or not. But anyway, all that aside, and that the fact that these games get very complicated very fast. I mean, like you can explain Pokemon again like to like a 5-year-old and they get it, right? But like coding it's so much harder, right? But hopefully you're seeing here how the classes are allowing us to like break our problem down into a much more manageable problem, where each of our functions is like, like this big, and we don't have to think like a ton about what's going on. We do, but we're throwing the details into other functions and other classes so that the problem doesn't build up. And again, if you're writing your own code and it's getting beyond about this big, you probably really should be considering functions here and other class members to kind of consolidate whatever this big, huge chunk of stuff means. Okay. So we'll have our public section. Attack. Oh, we can just have it generate constructors for me. Code, generate, constructor. You need to give it both things. Thank you. Code, generate, getter. Oh, nope, it's just getters for these. Or both of these. Thank you. I want to write that stuff. Okay. So we're back in Pokemon. Pokemon still needed a constructor. Well, I guess we probably actually just need that here. One thing here is, right now we're going to have everyone's health default to be a constant, a static constant. Oh, and the attack, we need to call this one get damage. Okay, that's changed. Yes. There is no such thing as final in C++. But you notice that when I declared it as const. So can it change? No, right? So const is somewhat equivalent to final, but not in all cases that it applies to in Java. Yeah. So the question is, if I had left off const here on line 18, would it matter at all? If I never changed it, no, but it's more for like safety and precaution that doesn't get modified. We also probably should just, have a separate like way that Pokemon get initialized for their health instead of being 100, which maybe we do want to do it that way, and I'll go and take that back out. Oops. We're just going to get rid of this. Yeah, Noah? Yeah, that would probably be somewhere we might use const expression for that value, if it lets us. So yeah, now we can have our Pokemon have different max healths. They're not going to all start at 100. One other thing to kind of like consider is like there would be like lots of Pokemon, and so you'd probably like want some file that like records information about the Pokemon so you could be able to like read them in instead of having each of like your individual Pokemon hard coded into your program, because then it'd be like really hard for like your other creators on your design team to make new Pokemon or make new moves. So you'd probably want to list them somewhere. We're going to be lazy and skip that part because we don't have time in 9 minutes to accomplish that. But you can see like over here previously we had some other information for like each Pokemon. Like they had a name, they had an attack, they had a defense, they had what moves they have, like grass. The type was grass. They had like tackle and vine whip. And then over here for moves, right, we had like, okay, here's tackle, and like it has some type, and it has some accuracy, and it has some effect, and a chance to apply the effect to the opponent, and a chance to apply the effect to yourself, and chance to apply some status, right? Like things could get really complicated really fast if you wanted to take all of these things into account. But to try to get our game up and working faster, we're just going to hard code some Pokemon in here to make it run. But we still had some other things that we'd want to do. Well, we'll go over here into main and we'll add some of that stuff in. Not class. Oh yeah. So how do we make a Pokemon? Well, if we want to make a Pokemon, we have to kind of first list some attacks, right? So So what's the first attack you want to make? Okay, so quick attack. And then its name should be and its damage for quick attack. How much damage do you want quick attack to do? 20. Great. Okay. What other attacks do you want to have available? Faster attack. I don't know. Maybe have like, you know. Well, sure. Bolt tackle. Sure. Well, let's bolt tackle now. How much do you want bolt tackle to do? Again, like when you're considering these values, you have to figure out like what do you want your people's maximum health to be. But yeah, some of these might be a bit OP, right? And then let's make one more attack. What's sure. Sure, it does 100 damage. So, we now need to make our Pokemon. Who's your first Pokemon that you want to make? Professor. Okay, we have a Professor. So we can have Professor Oak. Okay, so their names are the first thing. So we'll have Oak and we'll have Chen. And then the next thing that we need is, okay, so how much health does Professor Oak start with? Let's make it like something reasonable where we can actually finish a game without like 20 rounds. Right? And then what of these moves, which ones do you want him to start with? Quick attack, and what else? Okay, and then we have Professor Chen. How much health does he have? Okay, and then we need to create a Pokemon battle. So pound include Pokemon battle. And then we have, and we'll have a battle between Professor Oak and Professor Chen. And then we want, you know, battle, dot battle, and then great. What is this? What does this say that it wants? Oh, it takes a vector. It takes a vector. So one thing that you're seeing here is there's this other constructor for a vector where you enclose it inside curly brackets and it will create a vector with those values. So that's why I'm able to put it in here rather quickly instead of having to say like std : vector of blah blah blah, then put it in. Yeah. So the curly brackets are actually something that's called like an initializer list, and you can make a constructor for the initializer list. But the vector does have one for an initializer list, which is what we have right here. Okay, so we're still not done yet. We haven't completed everything. So we still need to. Oh, I guess we didn't make this one correct. So this should be a const Pokemon reference attacker. Or maybe here we actually don't even need this. So how do you want to list these attacks out? What do you need to do? We need to print them out, right? Have some way for the user to enter them in. And we also need to actually go through the attacks the Pokemon has to be able to list them out. So we might have something like pound include IO stream. then you might have something like, you know, or and then here we might have something like, you know, for const auto reference attack in get attacking Pokemon dot code oh, okay, so we need to fix that because the typing doesn't let things work here, because when we get the attacking a Pokemon, we might modify it. So we need two different versions of get attacking Pokemon. One that returns a const reference, which we don't have, and we already have the one that returns the reference. We'll try to wrap this up on Monday so you can actually see Professor Oak, Professor Chen fight to the death. But then we'll start talking about inheritance.